Well, good morning. This is lessons 28 through 30. Starting right off on lesson 28, it's asking questions like three-fourths of what number is going to be 70. Okay, so in other words, three-fourths of what number is 70. The whole point of this is really remembering this concept. When you see the words of and is, they mean something. So it is of means times, or in this case, multiply. We don't use x, or we use dots. No, we don't use dots. So we say three-fourths, and if we have of what number, whenever you see what number, just throw an x in there. Is means equal, and then 70. So now you have three-fourths x equals 70. So the answer to that is going to be multiply both sides by the reciprocal, because then that will give you 1 times x. See, 4 over 4 is 1, 3 over 3 is 1. So I have 1 times x equals 70 times 4, which is 280, because 7 times 4 is 28 over 3. Now the question is, so that's the answer. Can you reduce that? Not much. I'd leave it as a fraction, but you could, if it worked out to be nice and even, reduce it. So what you're looking at in this lesson is remembering this concept. Something of something is something. One of those three things is going to be, in this case, an x. That's pretty much it. And it doesn't matter how complicated this is, it'll still work out the same way. So let me give you another example that may look a little bit more complicated, but it's not. So let's start with this concept. Say 2 1/2 of what number? I'm going to put WN, that's what your book says. What number? Oops, I'm going to use a different problem. Scratch that. 2 1/2 of 240 is what number? Okay, again, you have something of something is something. This is this times this equals this. So 2 1/2, we never multiply mixed numbers like this. We make this 5/2 times 240, or think of it as 240 over 1, equals something. Well, 240 over 2 is 120. And so 5 times 12 is 60. So in this case, 2 1/2 of 240 is 600. That's how we do that. So it is always what of what is what. One of those is going to be a letter you're going to have to figure out, and X is what I use. Your book will use, and it'll say, what number? Well, when they say what number, that means you're going to have a number. They may say what fraction, or they may say what decimal. Those are all options. So let me give you one that uses an example like that. They may say what fraction, I'm not going to write that out, I'm just say what fraction of 60 is 48. So again, something of something is something. So replace that with x times 60, I'm going to reverse them, equals 48. And divide both sides by 60, and I get x equals 48 over 60. That I can reduce. 48 is equal to 6 times 8. 60 is 6 times 10. 8 is the same as 4/5. So 4/5. So x is 4/5. And so in this case, because they say what fraction, give the answer in fractions. If they said what decimal, you would say, well, that's 0.8, and you would give that one. If it was a nice even number, you would just give it a number. In this case, it's not a number, it's a fraction or a decimal. And that is the first half of lesson 28. So the second half of lesson 28 is talking about, let's see, let's try this again. New sketch, create, don't save the old one. All right, the second part of this lesson is going to be this concept of function notation. Okay, what you're going to have to do is memorize this thing, because that will help you a ton. And you say, what is a function? Somebody asks you that question, say, like, what is your name? You give them your name. And it's the same name every single time. In this case, somebody asks you, what is a function? You would say, oh. You make sure you say it really high. Say, oh. A function is just a formula that formula is identified by a letter. In the formula, the algebra variable is another letter. That's something you need to memorize. I know it seems really long, but as I do about 10 of these, you'll go, oh, okay. So I'm going to erase this, but I'm going to give you an idea. Cool part is once you see a few of these, you'll be thinking, oh, I am so good at math because I know what functions are. You can go to cocktail parties and people will be talking about how much money they make and what their tennis score is. And you can say, hey, but I know what a function is. So here's how we write functions. Remember what I said? What is a function? Well, a function is just a formula. So I'm going to give you an example. We pretty much see three types of them, three letters. Function with X in it. Sometimes we call it a function with G in them. And sometimes they're a function with H in them. So when I said, okay, what's a function? A function is a formula, and it's identified by a letter. The three letters that we generally see in algebra are going to be F, G, and H, just because they're three letters. So, a function is a formula. It's identified by letters. So this is formula F, this is formula G, and this is formula H. Okay, well, what is the formula? The formula is an algebraic statement of some sort identified by the letter X. So for example, X plus 2 might be a formula. Or you might have a formula of 3x to the second power plus 9. That's a formula. So this would be formula F, this first one. This is formula G. And what is the letter in the formula that we're working with? That's what goes in these boxes or these parentheses here. So you make up another formula, say 2 minus x. That's another formula, H. These are just names of the formula, and then what letter you're using in your algebra goes here. So you could have a name, okay, I'm going to have a formula called J, and it's going to have the letter y in it, and that's going to be 2y squared minus 4. Okay, what's the formula? It's formula J. What's the letter in the formula? It's y. Make pretty sense? Okay, this is called functional notation. Functional notation. Now, you'll notice that that big old long paragraph, when I said, what is a function? You say, oh, a function is a formula. It's identified by a letter. And that letter has, inside that formula, there is a algebraic variable that we work with. Okay, that's a long sentence. This is a very short thingy, and it's very useful and, as we say, functional. Hey, where did you hear that word before? So let's give you an example. We call this thing functional notation. It's a way to write formulas so that you could do all kinds of stuff in math. So it's kind of a shortcut of how to say stuff. So for example, here's a formula with x in it, and that formula is x plus 2. Okay, what would that be if that formula had a 5 instead of an x? Well, that would be 5 plus 2, or 7. So the formula with a 5 in it would be 5 plus 2, or what to solve it. Well, what if that formula had a negative 3 in it? Well, that would be negative 3 plus 2, which would be negative 1. So this is a way to give a formula, and then you can basically substitute all kinds of different stuff into that formula to figure out an answer. This is what it makes it so useful. Or here's another example of, okay, let's say I've got a formula G, and it's got an x in it for its variable, and that is x times x squared minus 3. Now, in the past, we would say, if x equals 2, what's that? Well, okay, we're not going to do that. We're just going to say, what is g of 2? So we read that g, you see this thing, you see the word of, and you see the thing inside, and you say 2. That's g of 2. That's different than multiplying it times 2. So you're not saying g times 2. You're saying the formula g with 2 instead of that variable. Well, g of 2 is 2. Everywhere you see an x, you put a 2 there. And then you just do the math. Well, 2 to the second power is 4. 4 minus 3 is 1. 2 times 1 is 2. So in this case, this was one of the practice problems from lesson 28. That's your formula functional lesson. What is a function? Oh, it's a formula. It's identified by a letter. That formula has a variable in it. And this is what that formula is. That's what a function is. Okay, done. See, that was so clever. And I honestly have experienced years of not really understanding this concept because nobody ever explained it to me correctly. So let's go on to lesson 29. Lesson 29 is about exponents. So you're very familiar with something like 5 to the second power. That's just 5 times 5, which is 25. Okay? You know how to do that. What if you have 5 to the negative 2? What is that? Here's the deal. If you see a negative number in the exponent that doesn't, D-O-E-S-N-T, doesn't mean negative, okay? It's a clue. It's a directions. This is like treasure map, directions in algebra. Okay, what it means is that you could rewrite it as a fraction. In other words, that negative means it's 1 over that, and then just make it positive. So since you know 5 squared is 25, so the answer is 1/25. So if I were to say, okay, what is 5 to the negative 2? The answer is 1/25. Okay, but there's a couple of steps. First, make it, put it on the bottom, and then go ahead and do the work. All right, so that's what negative exponents mean. There's another piece to that, and that is, what if you have 1 over 3 to the negative 2? What if the negative is on the bottom? Ooh, that would not be good. That means that's 3 to the 2 over 1. So in other words, if it's on the top and it's negative, put it on the bottom. If it's on the bottom and it's negative, put it on the top, and it becomes positive. And so in this case, that's just 9, because 9 over 1 is 9. And so that's the deal. Your book will say 1 over x to the n is equal to x to the negative n. In other words, a negative exponent means here it means a positive exponent there, and vice versa. Okay, and that is the deal with negative exponents. So you get to do with a bunch of problems. So, but it also works. Let's say you had something like x squared times x to the negative 3. And you go, I don't know. Well, that's x squared over x to the third. If you think about it, that's x times x. This is x times x times x. Cancel, 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 cancel. The answer is 1 over x. This is pretty amazing that it actually works, which is equal to x to the negative 1. But as you remember the rules of exponents, you can just add the exponents. What's x squared plus x? What's 2 plus negative 3? Negative 1. So it's not only a clue of a treasure map, but it also works with the math of it, where it follows all the rules of exponents. So you're going to be mixing up things, where sometimes you're going to have positive and negative numbers on the numerator, sometimes you're going to have negative numbers in the denominator, and you multiply them. I'm going to use an extreme example of this, and this is where you'll take some practice. So do not be afraid. You will get better at it, but you need to master this. Let me give you an example. This is one that's on page 123, page 123, if you want to go back and look at it in more detail. So you have a number like x to the 5th times z, parentheses, p to the minus 3 minus 4x to the minus 5 times z to the minus 1. Okay, now you're looking pretty complicated. But remember, this is just the distributive property. You've done lessons like that before. You're saying this times this. Well, okay, that's x to the 5th, z, p to the minus 3, minus this times this. Well, that's going to be 4. I always put the numbers first. X to the 5th, x to the minus 5th, z to the minus 1. So z times z to the minus 1. So I'm just saying this times this, 4, x times x times that, and this times this. So I'm just writing it out. Well, in this case, if I'm going to write this without negative exponents, that one would look like that. Minus 4. What's x to the, well, x to the 5th times x to the negative 5th. 5 plus negative 5 is 0. Okay, so I end up with x to the 0. And then z times, that's z to the 0. Okay, almost done. Here's the last part of lesson number 29. Anything to the 0th power is 1. 5 to the 0th power is 1. 1 billion to the 0th power is 1. X to the 0th power is 1. Z to the 0th power is 1. So in this case, that's 1, that's 1. So it's just, that's my answer. Okay, I'll do another one, and let's see how you do on this one. I said, it seems complicated, but that's as complicated as it gets. Once you get it, you'll get it, and you won't ever make mistakes on this again. So let's give you one that's an example from your lesson. And here you have, this is letter J from your lesson. 2x to the minus 2, y to the 3rd, parentheses, using distributive property and all these exponent rules. X squared, y minus 3x to the minus 1, and y to the minus 3. Okay, so the instructions of this is simplify and write it with no negative exponents. Okay, so let's this times this. I'm just going to write it out 2x to the negative 2, and I keep the x's together. Y to the 3rd, y. Okay, so that's this times this. Minus, because that's what that is, 2x negative 2, y to the 3rd times this, which is, 2 times 3, I'm just going to write that as 6. And then I'm going to x to the minus 1, y to the minus 3. Okay, so now I'm going to combine all these things. So I've got 2 That's equal to 1. In other words, that's x to the 0th, which is 1. And this is equal to y to the 4th. Minus 6. Well, here's x to the negative 2, x to the negative 1. That's x to the negative 3. I cancel them as I go. Y to the 3, y to the negative 3, and that's it. So since it says I'm going to simplify, this is simplified. But if I say no negative exponents, it's going to be 2y to the 4th minus 6 over x to the 3rd. And that's the answer. Okay, so that is lesson number 29. A lot to think about this week. Go back and review it, look at your book, and make sure that you ask in class stuff. Okay, lesson 30. And these are called algebraic phrases. Lesson 30. In other words, trying to go from English sentences to math. Okay, so a couple of things you need to know. Sum means add. Difference means subtract. Product means multiply. And quotient means divide. Okay, you need to know that because you will see that in examples. So look on page 125. I'm not going to go over those right now because it'll just be duplicating what's there. There's a whole bunch, as a matter of fact, there's about 10 of them, where they give you a sentence, and then over on the right-hand side, they write it as a algebraic expression. All right, so I'm going to give you an example of that. So you might see something like this is practice problem A. 5 times the sum of 3 times a number and negative 5. So what this is asking is it's saying take this and turn it into a math equation. In the case, it's not an equation because there's no equal. If it says is, remember is means equal something, well then you solve it. In this case, you're just writing kind of one half or one side of the equation. 5 times, so you're saying 5 times something. Well, I don't know what I'm doing. So that's 5 times. The sum, so I'm going to add 2 things. It's the sum. What am I adding? 3 times a number. 3, you can use the letter N. I'll use X. And what are you saying? A sum of 3 times a number and negative 5. Okay, so it's 5 times 3x minus 5. That would be the expression. Okay, and that's the first half of lesson 30, is being able to take these sentences and turn them into algebraic expressions, or in other words, one side of an equation. If it says equal, which it will in future lessons, then you're actually solving it. So you're writing the equation and then dealing it. Okay, last one is just kind of a review of what we've done before, but using the decimal concept. So remember what something like what fraction of something is something, or something we're going to do this time. We're going to say something like 0.32, that's a decimal, 32 100ths of what number is 24.32. Well, you can use a calculator, but again, blank of blank is blank. Blank, sorry. And so it's always going to be the same. 0.32 of means times what number. I'm going to use x. Is equal of means times what number. I'm just going to use the letter x, not wn. I don't like what number, leaving it as 2 variables because you think you're multiplying 2 things. So this of this is this, 24.32. Well, we just do this like we've always done it. Divide both sides by 0.32. These will be 1, and I get x equals whatever that is. Use your calculator, and you get a nifty number. It turns out if you did that, it would be 76. So when they ask anything about decimals, just put a decimal there. Okay? And whatever your answer is, just use your calculator and solve it. That's all you have to do. So it's blank of blank is blank. What of what is what? That's always going to be something times something else equals something else. Okay? And we are done with this lesson. So congratulations. I will see you